I want to try to give you a quick example of how to conduct a hypothesis test for the difference between means. Now, in my last example, I showed you how to write a null and alternative hypotheses. So let's just go through this, and I'm going to show you how you can use your calculator to run a hypothesis test for the difference between means. Here's my example. American League Baseball teams play their games with a DH, a designated hitter, meaning that pitchers do not bat. The league believes that replacing the pitcher, traditionally a weak hitter, with another player in the batting order produces more runs and generates more interest among fans. The average numbers of runs scored in American League and National League stadiums for the first half of 2001 are given. Does this data give evidence that using a DH leads to more runs? So in a previous example, I looked at my null and alternative hypotheses, and you can see basically this says the average runs for the American League is greater than the average runs for the National League. So I can write my null and alternative hypotheses like this, or I could write my null and alternative hypotheses like this. This says the same thing. The mean for the American League minus the mean for the National League is a positive number. If I subtract those two, it's going to be greater than 0 if the American League using a DH leads to more runs. So the next thing I should do with this hypothesis test, well, the first thing I should probably do is make a box and whisker plot of the data. I'm not going to do that. I'm going to let you do that and work with your teacher when it comes to that. I'm going to go ahead and jump straight to the assumptions and conditions. Were these chosen at random? Yes, they were chosen at random. Or, since this is a sample, the randomization condition is satisfied because the sample represents the population, okay? When I check my nearly normal condition, what I would want to do is create a histogram for the American League and a histogram for the National League, and those do end up being nearly normal. And then, are they independent groups? Does the scores in the National League, do they affect the scores in the American League? And the answer is no, they should not. Especially in 2001, those two didn't affect each other, so they are independent groups. Not that the stadiums are independent of each other, it's that the groups are independent of each other. All right, now that all the assumptions and conditions have been satisfied, this is a two-sample t-test for the difference between means. So I'm going to go ahead and jump straight to my calculator. Again, I'm trying to go as fast as I can. And I didn't show you this. Let me clear this out. I didn't show you this, but in my calculator, I have the data. I didn't show you the raw data, but here it is. So L1 is the American League, L2 is the National League, and you can see the average for each stadium, 11.1, 10.3, 9.4, and so on and so forth. So American League, L1, National League, L2. So stat, tests. This is a two-sample t-test. Number 4 right here is what I want to use. And I am going to use data. Since I have the data in my lists, I'm going to select data, and I need to tell the calculator what to use. List number 1 is going to be my American League, so that was in L1, so I hit second number 1 to change it to L1. List number 2 is my National League, so I'm going to hit second number 2, and that becomes my National League data. Frequency 1, frequency 2, just leave those as 1. You don't have to worry about that right now. This symbol right here should be the symbol in my alternative hypothesis. So my alternative said that the mean for the American League was greater than the mean for the National League. So I need to highlight this symbol. Okay? Then it asks you if you want to pool your data. To be on the safe side, we're going to say yes. We are going to pool our data. If you say yes every time when you're looking at the difference between means, you're going to be okay. Oh, there's an announcement going on, but I'm not going to redo this video, so sorry about that announcement. All right, now I hit calculate. And when I see what I see here is everything that I need. I'm going to pull this into my document so that I can highlight some things. Let's scroll down. And what does the calculator tell me? Well, the first thing that it gives me is right here. That right there is my test statistic. The second thing that I see is my p-value. So right there is my p-value. So I can see that my p-value is 0.76. Well, if my p-value is 0.76, most of the time alpha is going to be somewhere around 0.05 or 0.01. So even if I say 0.05 or 0.01, my p-value is more than alpha, which is my my level of significance. And so that means I am going to fail to reject the null hypothesis. So in this case, since I am failing to reject the null hypothesis, that tells me that the DH does not lead to more runs. Because I'm okay with the null hypothesis, that means I'm not okay with the alternative, and the alternative says that the American League has more runs than the National League because of the DH. Well, guess what? There is a difference between the two leagues, but it is not a significant difference between the two leagues. So my null hypothesis is going to be true, according to my data. Hopefully this helps. Hopefully it gives you an idea of how to conduct a hypothesis test on your calculator, and have fun in your stats class.